Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be having another episode of PC Archaeology, and we're going to be looking at this IBM PC XT clone machine. These clone machines were incredibly ubiquitous back in the mid-80s all the way through to probably the early 90s, and if you had a no-name clone that was an XT or a 286, it probably came in a case just like this one. So in this video, we're going to take a closer look at this machine, see if we can uncover any of its secrets when it comes to where it came from, how it was used, and then we'll see if it works, and if it doesn't, try to do a repair, and then play a game on it, because that's what you want to do on your PC of this era. Not word processing, but gaming. So without further ado, let's get right to it. The humble IBM PC XT clone. While this doesn't look like an IBM PC XT or the original PC, the cosmetic look of these cases was designed to mimic the IBM PC 5170, the 286 AT, even though almost always these were very low-end computers. They just came with XT motherboards. And that's because internally, we're going to find this thing is going to be exactly the same as the PC XT. It's just the front faceplate is changed to give it that 5170 look, that faster, I have a 286, I spent more money look. Even though, as I said, these are almost always XTs inside. Now, if I put an IBM PC on top of this, you'll see that it's basically identical in size. These clone manufacturers did give you a quality of life improvement over the original XT though, with a reset, turbo button, hard drive, power LED, and a key lock switch. It was quite common in the days of the IBM PC and the PC XT that people would add a reset button on the back side of the computer, because otherwise you'd have to turn the computer off and on if you had a hard freeze. While the 5170 added the key lock switch plus the power LED and hard drive LED, they still didn't bother with the reset switch or of course a turbo switch because this is a single speed computer, but that meant you had to power this on and off if you had a freeze, which does happen sometimes. So it was really kind of lame on IBM's part to not even bother with a reset switch. Now, even though the styling of the clone is very similar to the IBM PC 5170, this is a much bigger case, and it actually has an extra drive bay below these two. It's just not exposed through the front bezel, but it is there and it's usable, but this also does have a full-size bay next to it, usually holding a hard drive or multiple hard drives. So the clone manufacturers were trying to get away from the XT look, even though you were still buying a very inexpensive computer, by styling this after the 5170. But this doesn't have the large physical presence or size of the 5170, and internally it's actually structured exactly like an XT. It cannot accommodate a motherboard from the 5170, which is quite a lot larger. It could only fit what was known as a baby AT motherboard, which is pretty much the AT motherboard standard that you're used to, like kind of long and skinny. And that's really what the original IBM PC established as its standard. You could get up to Pentium motherboards in that form factor, so if you had one of these cases with the XT power supply and all the XT sizes inside, you could have upgraded this all the way to a Pentium. That would have been very common back in the day if you had one of these, that you either went to a local computer store in your town or city and you bought one of these from them and they would have assembled this from parts, or you ordered one of these from the back pages of Computer Magazine. There were often ads just filled with parts you could buy, cases, monitors, keyboards, motherboards, all that stuff. And you could either buy those parts separately and build a computer yourself. I mean, people are happy when they build themselves a gaming PC now, but people were doing that back in the 80s as well. But this computer has a very reflective badge on it, which I'm trying to get the camera to focus on. It says NCC Turbo XT. If you bought one of these cases and assembled the computer yourself, it wouldn't have had a badge there. It might have come with one, but it wouldn't usually, so you just have a blank space there. The clone manufacturers did copy the IBM 5170 case though, the larger size of it, and it could accommodate full-size AT motherboards. So typically if you were going to be ordering yourself a 386 or maybe a fast 286, you would have gotten the larger size case, the AT case. Even though a baby AT motherboard would have fit in a case like this, it was just typical to get that larger case with an actual AT power supply, because even though this case does have the chonkin power switch on off, the IBM PC AT power supplies that went in the larger cases like the 5170 or its clones were physically larger. The switch was the same, but the actual power supply was quite a bit larger and it wouldn't have fit in a case like this. It just actually needs more height. So let's take a look at the back of this computer. Let's see if we can figure out any secrets about where this thing came from. Well, we can tell right off the bat that this is absolutely a PC XT, and the circle for the power supply exhaust gives away that this is a normal XT power supply. The fan's mounted on the top of those power supplies, and it actually exhausts from this circular vent with these slots in it. This case does have a few badges, which we'll take a look at in a second. As is normal for the XT power supply, it does have a pass-through. You would typically plug in your monochrome monitor into the pass-through, so when you turned on the power supply, it would actually turn on your monitor for you. The case has the usual assortment of things on the back. We have 2 DB25 spots that aren't used, a keyboard jack, and then we have room for 8 slots. It appears that this thing has a modem in it. We have what is most likely a game port. It could also be an AUI port for network expansion, but the fact that it has an empty space underneath here means it probably has a ribbon cable that connects one of these cards, and that is definitely not a network connection. We have a 9-pin serial port, we have a parallel port, another parallel port, and the video connector, most likely monochrome video, MDA, and that's because it's sharing the same card with a parallel port. And when IBM released a CGA card and pretty much all the clones came out, they didn't include parallel ports, although occasionally they did, but usually it was just a 9-pin female connector like this for your monitor, and you would have to use something else with a parallel port. All right, let's take a look at these badges. So on the front it said NCC, and on the back here it says National Computer Company, 8483 Southwest Canyon Road, Portland, Oregon, 97225. It does have a serial number, XT8800 0664. So they built 664 of these machines, and model number was just simply XT Turbo. There's a small sticker above that says micro, it looks like, and it has a stamp with 88 and then handwritten 30. I wouldn't be surprised if this is 1988, and this sticker might have come from the supplier of the case. So it's very common in cities all across America. There would be wholesalers that would sell these types of parts, things that were imported usually from Asia, and then these wholesalers would sell their parts to stores, which would then assemble the computers to sell to consumers. So we'll see if we see any more of these stickers on the inside on other parts. Typically, companies like this National Computer Company would buy all their parts from the same supplier, and you would find these stickers on motherboards and hard drives and floppy drives and all sorts of things like that. Kind of like a warranty sticker for the wholesaler when it came to parts getting returned from the companies that were putting these together. I worked at a computer store in the 1990s in Los Angeles, and we had a similar supplier. I think it was called Elenco. And all of the parts and stuff that we would use to assemble computers all have these Elenco stickers on them with serial numbers. All right, there's one more sticker, and it says, inspected and labeled by Electrical Safety Section of Department of Commerce, State of Oregon. This sort of implies to me that this thing might have been used by a government agency, although I don't really know what was happening in Oregon back in, well, say 1988. Maybe everything that you were selling to consumers needed to be inspected for electrical safety, or they were probably just looking for a UL listing or CSA listings on the power supply, and you would just get a roll of these stickers and stick them on everything. If anyone watching lived in Oregon back in the 80s and has seen stickers like this, please comment down below. Just let us know if this has something to do with the government agency requiring inspections, or this was something that every consumer sold PC had. Otherwise, on the outside of this computer, things are pretty much run-of-the-mill. We do have some signs of scars and stuff, little scratches and little bits of rust that are forming. I did give this thing a thorough clean on the outside when I first got it. Same thing there, we have a little scratch, a little scuff down here. I mean, just minor cosmetic stuff. All things considered, this thing held up really well for an unused and unloved IBM PC clone from 1988. Now, I just took a moment to try to find any evidence that this NCC, or National Computer Company, existed at that address. And that address is sort of like a little mini business park. There's about 4 or 5 businesses that look like they can be in there. And I could find absolutely zero info about this company ever existing. A few things I figured out is that that address now actually exists in Beaverton, Oregon. It looks like they annexed that address at some point in the 90s. There seems to have been businesses like law firms and a vet at that address, and I think the law firm had some kind of sketchy stuff going on with the government because I found some articles about that. But as far as this NCC company, I could find absolutely no business records anywhere about this company. I did find a company up in Washington that looks like a computer company that builds computers called NCC Computer. I emailed the person who owns that company, and they said they had nothing to do with this one here in Portland, so that was a bit of a dead end as well. I have an issue of Computer Shopper PC Clone that I scanned a while back on archive.org. And I'm really curious, if we look through this 1987 issue, if we actually find a clone that looks exactly like this. I don't think we're going to find NCC. We should be able to find the computer. Okay, there's a company selling clones. Ah, okay, so this is a clone of the 5170, the PC-AT, so full-size case. Oh, look. There it is. There's the freaking case. This is 100% without a doubt the same exact case. Same control panel, has ultra branding, and even has the floppy drive. This is a TIAC on the bottom position. $479. That included the 10 megahertz motherboard, 256K of RAM, 150 watt power supply, 5150 style keyboard, TIAC or Toshiba disk drive, and a floppy disk controller, all for 479 bucks. Wow. You could add an extra 90 bucks for the monochrome monitor and another $69 for a printer. Complete system, $638. And I was not able to find the exact month that this magazine was published, but it was 1987, Volume 1, Issue 1. And I wouldn't be surprised that a bunch of the components we're going to see here are probably what's inside of this computer. I'm not saying it came from this computer company here in St. Louis, Missouri. I'm just saying that these companies were all over the place and they were using the same parts. But going down a few pages, and there's another clone. Now, this is not the same exact case. Notice it has vertical slats, doesn't have a reset button. This almost looks more like a clone of the 5170, but this is an XT, so I wouldn't be surprised if this is a smaller case as well. Speaking of the date that this was published, there's actually a subscription offer from July 31st, 1987. Well, it says the offer expires then. So that means this magazine came out a little bit before that, which means that the clone we're looking at, that seems to be from 1988 based on the sticker on the back, came out after this. It would have been even cheaper than all of the computers listed in here. And look at this ad, IBM PC XT from $1099, and it was only a few pages up we saw the clone that was complete system with a monitor and printer for $600. That's why IBM lost. These clones obliterated them and everyone else because things were just so inexpensive. And take a look at this further down in the magazine, and as you get further down, things get cheaper because the ads are cheaper. 10 megahertz bare bones system with no floppy or no keyboard is only $299. You just add the components you want. And notice they say AT lookalike case. This one too, this is also a Turbo XT, AT lookalike. They absolutely copied the styling of the 5170 on these XT cases so you could buy a really cheap computer and have it not look like it was an old cheap computer that was out of date. Now, that's not to say that you didn't also have companies selling the old XT style case that were clones, like here's one for $999, which seems rather expensive. Although I can see here that actually comes with a 20 meg hard drive, so that brings the price up significantly. Oh, look at this clone. I had this exact case as my first PC. It had 3 exposed drive bays and it was an AT case, had a full-size power supply in there. I could take the full-size AT motherboard, but yep, it looked exactly like this. It was quite imposing and quite large on the desk, significantly bigger than XT's. Here's an ad from a company, Everlead Systems in Fountain Valley, California. And of course, it's trying to copy Leading Edge. Take the lead. There's our case again. That's exactly it. Compared to today, it really was like the Wild West. Now everyone just goes and buys a laptop or a pre-made computer. Of course, people do build their gaming rigs like I mentioned, and it's fun to put all those parts together. But the reality is most people just buy a laptop and they call it good. But back in the 80s, these clones were just exploding, and you can see it evidenced by this multi-100 page first issue of this Computer Shopper clone magazine. If you want to check out this PC Clones magazine for yourself, I'll put a link in the description below. And for now, let's get back to the video and look at what's inside of this computer. Okay, so at this point, I think we've done all we can do on the outside. I've taken the screws out. Let's see what we see on the inside of this machine. Usually you just slide forward to get the case off. Just watch that. Sometimes it catches some of the cables and things on the little back screw hole there. So I'll just hold it with my fingers and we'll slide this off. There it comes. Okay, well, as it said on the outside, it's a Turbo XT, and that's absolutely what it is on the inside. I don't think much has been changed with this, although we can see that this modem does appear to be a little bit newer than the rest of the computer. So we'll take a closer look at that in a second. I was curious when we looked at the outside to wonder if this thing actually had a hard drive in it, but it doesn't appear that it's ever had a hard drive in here. It would have sat in this exact spot. And if a hard drive had ever been installed in here, we would have seen witness marks, usually scratch marks, because you have to slide the hard drive in from the front and it would scratch over this and you would attach screws from the bottom or from the side. And without a doubt, no screws have ever been fastened to the side. You would see witness marks where those screws were tightened, which means this computer would have always been used with floppy drives, which is not unheard of. A lot of times if you had a single purpose computer, for instance, maybe they just dialed up to a BBS, they would have just stuck in a boot disk that would have had their terminal emulator program, or maybe they had 2 floppies, and that was that. And you'll notice that this 3.5-inch floppy drive is a 1.44 drive and probably has the date right there, August 18th, 1993. So this is definitely much later than the rest of the computer, which is definitely from the 80s. And if we take a look at the floppy cable, which isn't even connected to the 3.5-inch drive, it's the dual edge connector type, which definitely implies this probably just had two 5 1/4 inch drives originally, and then someone replaced this top drive with the 3.5. But if you look at the cable, there's no twist. That means that the bottom drive is the A drive and the 3.5 inch is the B drive. And it has the little adapter to connect the pin header to the edge connector, which you needed because they didn't want to replace this cable. And tucked away on the side is the little power adapter, since this power supply, I was going to say didn't have any connections for 3.5 inch drives, but there's a connection for such a drive that actually goes directly into the power supply, which is kind of amusing because this power supply is absolutely an XT power supply. You can see with the fan on the top, yet it has connections for 3.5 inch floppy drives. If this thing was built in 1988, 3.5 inch floppy drives were pretty new to the market. They were really just starting to become common on PCs. So having a connection for such floppy drives was kind of ahead of its time. I think the next step in this video is I'm just going to start taking this computer apart. We'll take out the components one by one, take a look at them, give everything a good clean. This is really grimy inside the power supply, and then see if we can get this thing actually working. So as I alluded to early on, this was not uncommon for people to build their own computers, even back in the 80s. And it's interesting because to this day, people are still doing that, but they're doing it with, gaming PCs. A lot of people just use laptops, but then they'll build themselves a gaming rig, so to speak, so they can play their games. And starting in the 80s, when these PC clones started coming out and all the constituent parts, which you could just buy through magazines, this was an excellent way to save money. And in fact, my entire life, well, working with PCs that is, I always built my own computers, including my lab machine that's here on the bench up there and my editing PC upstairs, or things that I built. But I started working in a computer store building PCs for customers, so a lot like the company that made this. And that gave me that knowledge to be able to do it for myself for basically the rest of my life. So all the computers that I ever had, including my Pentiums and 486s and everything after that, were always things that I built myself. And it's all started with these clone machines exactly like this. Okay, so here's a little bit of a tidbit that sort of is a carryover from the old IBM PC XT days. You always had screws on the outside to screw your drives in, but there were also holes on the bottom of the case that allow you to screw at least the bottom drive in from the underside. Well, I took out 2 screws on the side here and, well, this floppy drive is already loose, so this was never attached on the bottom. But I wanted to point out that there are witness marks from the screws that were holding in the 5 1/4 inch disk drive. We also have a small witness mark for the 3.5 inch or whatever floppy drive was installed at the top, visible at least on this front hole. But on the bottom one, it's on both. And if we slide this floppy drive out, I'm going to lift it up and slide it out. Let's see if we have evidence of scratches from it being installed in the case. I'd say no, it doesn't appear to have any scratches. You can see where the dust is less, where the drive was sitting. So there and there. But I don't really see any scratches. But as far as the hard drive bay, which is what I was trying to compare to, I don't see where any kind of drive would have been sitting where it would have been removed, unless it was removed a very long time ago. So I really don't think a hard drive was ever installed in this case. All right, next up is the interface cards. We have the video card and parallel port, and it doesn't even have a screw. The card next door is the multi-IO floppy thing. It even has a battery on it, so clearly that's got a clock, which being an XT, those were not standard on the motherboard. So let's first try to get this video card out. Oh, those have a firm connection. We'll take a closer look at the parts I removed from this computer in a second. So that is that game port, and then we have the modem. Now on the motherboard, there are connections for various things, and I do need to keep track of what's where. And that's because there isn't always documentation for these motherboards, and we have 3 connections there. I assume this maybe was connected to JP1 at some point. It's just not connected now. It could also be the hard drive LED that's not used. But there are more connections that likely go to the front panel. In fact, yeah, I can see this one does. This is a blue and white wire, and I can see it sticking out there. That goes to JP3. And then there's a further 2-pin connection here that both has a gray wire on JP4. Most likely that's the reset circuit, but it could be turbo actually as well. So before I unplug this, I'm just going to take a photograph with my phone just so I can keep track of what's where, so it's easier to reconnect. And not to mention, when I get the case apart, we can take a look at what goes to what on the front panel, so I can see which is the turbo and the reset, because nothing's labeled. It just says JP5, JP3, JP4, that kind of thing. Removing the power supply is quite easy. There are just 4 screws on the back, and then you just pull the power connector off, which oddly is taped together. It's just tape though. These are 2 separate things. And then the power supply just pushes forward and lifts out. The motherboard is the last component to remove, so we'll just get these jumper links disconnected. And this one seems to have two force screws holding it down. And once the screws have been removed, we can just slide this towards the side of the computer, lift up slightly, and then it comes out. It's got these little plastic standoffs, which were used on AT computers. This got replaced with ATX with all metal standoffs, much easier. Okay, with the front panel removed, what is apparent is that the red and black wire that was left inside the case is for the speaker. And that wasn't connected. So that must be that connection on the front edge of the motherboard that I showed. And that's odd because that kind of implies that everything, including the hard drive LED, was connected. Okay, hard drive LED was not connected. It was just cut. Okay, kind of rude, but there we go. Okay, there's the inside of the case, and yeah, that looks a little bit like a nicotine glaze. So I'm gonna have to take this thing outside and hit it with the air compressor and maybe give it a little bit of a wash, because this is, yeah, it's kind of gross. I don't smell a strong odor of cigarettes, but the fact that this is so brown, that just really implies that this thing was smoked around, and maybe it was so long ago that the smell has dissipated, but yeah, that looks kind of gross. One thing I want to mention is that this thing is really quite solid and well made. It's all steel construction, and unlike cheap cases today, if they're not assembled with the lids and stuff, they're super flimsy. This thing is solid. And that's just indicative of these computers back then. They were really well made, even the cheap clones. Okay, here are all the constituent parts, and I have donned some gloves, and that's because I smelled my hands after taking the computer apart, and absolutely cigarette smell is all over them. So we have a nicotine glaze covering everything, which is why things kind of have a golden appearance to them. Ugh, imagine that's inside of people's lungs. This is a DTK Turbo XT motherboard, and we do have that same sticker with a 1988 on it and a 30. So again, I'm thinking this comes from the supplier of all of these parts. The motherboard being a DTK, pretty common. They were a big supplier of clone motherboards to these types of companies, and they were decent, good quality parts as well. The motherboard has another sticker with June 30th, 1988 date code, and what I presume is some kind of a serial number. If we look under the glaze that's on here, looking for date codes, 1987, 34th week. There's another one, 1987, 31st week. And looking at the RAM, we have 1986, 44th week or 45th week. This motherboard has a somewhat typical configuration of RAM, 512 kilobytes of RAM, and then these chips are 64 kilobytes times 2. So 2 of these is 64 kilobytes, so an extra 128 kilobytes gives you the 640 that is very common for IBM PCs. The motherboard does have parity memory installed, so you can see 2 additional RAM chips installed. So this one goes with these 2 RAM chips, so this is 8 bits, 9 bits total, and then these should have 9 chips total, and they do. Everything else on this DTK motherboard is pretty run-of-the-mill. I think there's not going to be anything on here that's non-standard. There's the DTK copyright and a model number, I presume, PIM TBIO-Z. And this motherboard is definitely kind of gross when it comes to the nicotine glaze. It's going to need a thorough washing. 10 megahertz turbo board. Moving on to the video / parallel printer card. It says printer / non-flicker, mono / graphic. So is this CGA or is this just monochrome? We'll actually be able to tell before we even plug this in. This UMC part, the 82C11, this has to do with the parallel port. This is like a parallel IO type chip. Underneath this larger IC is probably the 6845, warranty void, if removed, 11th week of 1987. Twin head, that actually is a name that's a little bit familiar to me, and I don't think I've ever noticed the logo. It's actually 2 heads with a circle around them. That's kind of cool. Now, all video cards require some RAM, and this one has 64 kilobytes of RAM, so 44 64s. That means each one of these is 4 bits wide, and so 2 of these 8 bits, and that is a total of 64K. Now, as a monochrome card, if that's what this is, 64 kilobytes is used for Hercules emulation. Otherwise, monochrome cards don't need that much. And CGA cards only use 16K of RAM, but if it has like Plantronics support, then 64K is also used. Now, looking at the output connector is going to help us understand what kind of card this is. If it was CGA, it would have pins 1 and 2 as ground, and then the next 3 would be the RGB, and then you have an intensity, and then the monochrome video signal itself, and horizontal and vertical sync. So the fact that we see all 4 of the pins on the bottom row connected means that this is definitely a monochrome card. and we need to kind of see if those top 3 pins, these 3 that don't seem to go anywhere on the bottom side, go to anything on the top side. And that would be a big fat no, because there's a big ground plane right there, so there's no way that those signals make their way to anything on this card. So this is nothing but a monochrome graphics card with Hercules emulation. I guess it's the CT6040S made by Twinhead. Awesome. I'm noticing there is one jumper installed V1 and V2. Oddly enough, they seem to have omitted bypass caps in certain circumstances or use disc capacitors versus this type. Oh, and there's one more jumper up here for printer on or off. Looking at the back side of the board, not a whole lot to look at. KDAC. Look at that, another sticker with a date, November 4th, 1988, and presumably a serial number, 8364. It's funny looking at the traces. They're all so right angle, but there are some that are at 45-degree angles. Obviously, their CAD package that they designed this board with only supported 90 degrees and 45 degrees as traces. That's pretty funny. All right, then we have the modem, and this obviously is a lot newer than the rest of the stuff. 1991 there. I'm assuming we have 1992 52nd week, so this was absolutely added after the fact. This is not one of those terrible Win modems. This thing will emulate a full serial port, but it's very cost reduced. Everything has been put into this chip here. Just a little bit of select logic. That's pretty much it. This one chip does everything. This is probably 2400 bits per second modem. On the back, nothing much to see except it says assembled in Mexico. Next up, we have the multi-IO floppy controller. Let's get this game port disconnected. When you see cards like this and you see that there are missing ICs, that's not a problem. That just means that it supports an extra serial port. And if we look at this little slot cover here, it actually has room for another DB25, which would connect to that connector. And you'd have to populate an extra UART plus a couple select logic chips or whatever to allow that to work. As I mentioned earlier, we have a real-time clock. This is the real-time clock IC, and that is the battery, and I'm sure that is totally dead. We have the very standard 765 floppy drive controller IC, which is for double density disk drives connected right there. I don't necessarily see a brand name on here. It says M10-100 Rev 6, made in Taiwan. We got jumpers all over the place, and no real way to know what any of them do. Ah, there is an FCC ID on here, and that will help us at least figure out the company name that makes this, maybe the model number, although there the model number is M10-100 again, that was printed on the front. The copper layer has a cool little logo there, and a date code of 1987, second week. No sticker showing the date, although who knows what fell off this thing on the years since it was put together, but maybe this was not the original card that was in here. Who knows? Next up is the glazed floppy drive. So this also has the date code sticker on it with a different serial number. So I guess they serial numbered all of their parts as they got them from suppliers. Maybe they put these serial number stickers on their supplies in inventory just so they could keep track of what went into consumers' computers. This X here is curious. It's been there for a very long time. This is disk drive broken. Side of the drive is nice and glossy. Copal Electronics Japan. Yeah, from a date code perspective, 1987, 20th week on that chip kind of dates when this drive is from. Is anyone curious to see what this looks like underneath? I did blow it out with the air compressor outside. Quite a bit of dust came out of it. I think this cover should come off. Oh, I think below this sticker might be another screw. No, there's just like a dent in the case. So they put that sticker on there to cover up a dent. That's funny. All right, well, it's not too bad on the inside. It's definitely glazed looking, but you know what? That moves very easily, very freely. So this probably will work just with a little bit of cleaning. Yeah, everything looks okay in here, actually. Okay, last but not least, here is the really grungy 3.5-inch drive. Is it a TIAC? Yes, it is a TIAC. This drive probably works just fine. It will just need some good cleaning. And yes, you can just use a normal 1.44 meg drive like this on an XT. It works just fine. This will work as a 720K drive at 250 kilobits per second. So it just ignores the high density switch, and you just have to either tape over the little hole on the floppy disks or just use 720K disks, and there is no problem with that. All right, well, I am super curious to know if this motherboard is working. I think I'm going to test this first using my own power supply before we even try this power supply, and let's see if it works. It's not uncommon on motherboards of this age to have shorts on the tantalums. Typically these little ones aren't that much of a problem, but then sometimes you have bigger ones like these here that are on the 12 volt rail. And these are typically 16 volt tantalums. And I guess the 12 volts is close enough that these typically will go short and potentially keep your system from working. If you buy yourself an old PC like this and that is the problem, then do not just assume that the power supply is the issue. Definitely check to make sure you don't have shorts on these tantalums. Now to do that, you just get a multimeter, set it to continuity mode, go between the ground pin on the power connector and go to all the other wires that have colors. Now you can see this one here is 80 ohms or whatever, that's completely fine. Even something like 5 ohms is fine, like 14 ohms is fine, even though it's beeping, we could ignore that. The reality is we're looking for something like 0.5 ohms or less than 1 ohm. And that was it. Yep, I don't think there's any issues with this motherboard, at least from a tantalum shorts perspective. Now, if you're trying to get back into PCs and you want to test stuff out, I recommend you get one of these little post analyzer cards. XT motherboards like this don't really have post codes, but this will show us the voltage rails, the reset line, and it will show some activity on the bus. Typically this number will just flicker and do stuff. And that's actually a really good diagnostic tool just to know that the system is working. Make sure you don't plug this in the wrong way though. If you aren't sure, just take a regular card like this and the components face the power connector. So same with the post analyzer card. All right, I am ready for testing. So this is an ATX power supply that has an adapter on it. It goes to AT. Let's tilt this up so you can see the lights and stuff. Ooh, let's hook up the speaker in case this machine is beeping at us, which it almost surely will because there's no video card installed. So I'm going to hold this up so you can see everything that's happening. Let's turn this on. Good. This is excellent. Ignore the fact you don't see a postcode. That's completely fine. What's good is we have what looks normal and we had beeping. The CPU has to be running for the computer to be able to beep at all to us. So it's telling us there's an error of some kind. It's probably telling us that there's no video card installed. That is excellent. And all these lights look perfect. So for testing this machine, I have this twin head video card plugged into it, and I'm going to be using my RGB to HDMI to capture the video. We've already established that DE9 is wired up for a monochrome monitor. That means if you plug a CGA monitor into it, it's going to be the wrong scan rate. So don't do that. You're also going to get no image. But the RGB to HDMI is a great way to basically get video out of whatever it is because it's super flexible. If you're not sure what kind of video signal is coming out of this, use something like this, a very cheap oscilloscope, and you'll be able to see that the horizontal sync pin is going to be around 18 kilohertz for MDA, and then the vertical sync is going to be around 50 hertz for MDA. And then you should see some video activity, if the card is working, on both the monochrome video signal, which I think was, what, pin 7, and then the intensity bit, which was on pin 6, if I recall. I have the RGB HDMI connected though, so we are going to select the correct profile for this, which should be MDA or Hercules. The timing can vary slightly from one card to another, so we'll just pick MDA, and it probably should give us mostly a good enough image. Okay, let's try our second power on and see if we get any picture out of this thing. Well, that's odd. And I'm pretty sure we have a bad video card. So we can do source summary, and this will give us some info about what it's getting. Now, normally, if the sync was being detected from the card, it would have a frame rate, sync type, horizontal sync, all that stuff would be visible here, but it's not showing anything. So I'm going to use this VTech card, which I always use. This thing has CGA and monochrome capability. There's a little toggle switch here. Because I'd like to know if this machine is working, or maybe there's a bad slot. There could be all sorts of things wrong. All right, we have video. It says DTK URSO BIOS 2.4, 1986, DTK computers, 1988, keyboard error, RAM test 640K, that passed, and we have a disk error, boot record not found, strike any key to reboot. Yeah, sweet, so this motherboard works, or at least it appears to work. We'll have to run some further diagnostics. I'm really not surprised. These clone motherboards are very reliable. If anything, IBM motherboards are less reliable, and that's simply for one reason. The tantalums that IBM used seem to go short, and on these DTKs and these other clone motherboards, that just doesn't seem to be the case. So what I want to do now is hook up a keyboard, and I went and grabbed this XT keyboard. It is a Magnum brand. I don't know much about it. I don't even know if it works, but let's plug it in, see if it does. Keyboard had a flashing light. Keyboard error. Okay, this might actually be an AT keyboard. I don't know. There's no switch or anything on the back. Pushing keys doesn't do anything. Does have a num lock and a caps lock key, and they light up when you push them, so it's got power, but otherwise it's not working. Now, because this motherboard is completely unknown, as is the keyboard, it would be difficult if this was my only keyboard or my only motherboard, because I don't know where the problem lies. Is the problem with the keyboard, or is the problem with the motherboard? Luckily, I have another keyboard that I know works for sure. It's an AT XT switchable one, so I'm gonna go grab that. But unfortunately, if you're stuck with an unknown keyboard and an unknown motherboard, it's going to be kind of difficult to figure out where the problem lies specifically. You might have to try to analyze the signals coming across the keyboard connector when you push keys to try to see if it's XT or AT protocol. That's not super easy unless you have a logic analyzer or you really sit there and try to capture the frames when you push keys and then decode the signal. This switchable AT-XT keyboard though, I know works perfectly, and I just switched it to XT, and I didn't reboot the computer, and I pushed keys and nothing's happening. I'm gonna power cycle the machine. Now what I'm thinking is possible is that the key lock switch might be the issue. And it could be that the default configuration is where the keyboard doesn't work, and it says keyboard error. And that's because you need to have that front switch connected in order for it to make the keyboard work. So looking at this small contraption I took off the case, cable that was for the key switch was this blue and white wire. All right, there's the blue and white wire. It's JP3, which is right there. Now, if this actually fixes it, this is a bit unusual. Usually you don't need to have a jumper in place for the key to be unlocked. You have to put one in place for it to be locked. But this was early days and this was a bit of the Wild West at that time, so who knows what DTK did. Okay, rebooting the computer, and now it doesn't say keyboard error, so that was absolutely it. You have to have a jumper there to actually get the keyboard to work. So that's a trap for young players. People might get caught up on that and think that they have a problem with the keyboard or the motherboard, when the reality is you don't. And look, Control-Delete totally worked. I'm gonna switch back to that other keyboard, the Magnum. I wanna see if that keyboard does work. There's a lot of beeping out of this computer. It's very insistent that you pay attention to it. Look at me, look at me. Okay, I have the Magnum keyboard reconnected, and I'm gonna power cycle the computer. I assume that's the initial beep. Yeah, okay, no keyboard error. So I guess this Magnum keyboard is an XT keyboard. Okay. Let's see if Control-Alt-Delete reboots. It does indeed. Okay, we're making really good strides. The motherboard appears to work. The RAM seems fine. Keyboard interface is working with that jumper installed. We don't know if the turbo is enabled or disabled yet. Let's try to go back to that other video card because we know that this slot is working, and I want to see if this card can be made to work. Maybe it's dirty. It's not dirty. This is actually pretty clean. So let's pop this into the same slot that I had the other card in. And let's just make sure this card is definitely not working. Okay, here we go. Let's try again. No, same thing. Okay, without a doubt, this card is bad. So I guess that means future repair. So I went back to the working video card, my VTech card, and I'm gonna try this floppy controller. And let's take the battery out here. Hasn't leaked or anything. That's nice. Let's see if there's any kind of voltage in it whatsoever. 1.25 volts. Wow, that's pretty surprising. It's a Rayovac 2325. Good battery indeed. Is that a date code from 2006? So someone was using this in 2006, this computer? Is that even possible? I suppose it is, but highly unlikely. All right, so in goes the multi-IO card. I was gonna try to use this floppy cable, but the glaze on there it's too gross. I don't wanna use that. So I'm just gonna use one of my own cables. This one happens to have a whole bunch of extra connectors on it, which is kind of perfect, because we're gonna try to see if this floppy drive works. All right, here we go. Let's turn this on. Everything's powered up. Let's see if this thing seeks. I know you can't see the video right now. I just wanna see in frame. Hey, good sign, right? Good sign. And there we go. We got no errors, just no boot record found. Why don't we try to clean the heads on the floppy drive? I have a cleaning disc. Right, so let's hit enter. Oh, well, that's not good. What happened is it's having trouble spinning the disk. It's working better now though. So let's try booting this Compact DOS 4.01. Should work. Let's hit a key. All right, so the activity LED went on and then came off. The disk could be bad, it's possible, but doesn't appear to be booting. All right, so we're running into all sorts of issues, and this is very typical with hardware of this era. And just sort of a warning to people, if you are trying to get into this era of systems and you don't have a bunch of extra hardware for testing, like extra floppy drives, extra keyboards, you can really get stuck in so many ways. Right now the system's not booting. Is there a problem on the motherboard? It is possible. Is the floppy controller bad? This multi-IO thing? Is the floppy drive itself bad? There's all sorts of possibilities. Now I have my XT IDE with a bootable compact flash, and I know that this card does work on other systems, but One of the issues with this card is that it uses a base I/O address, I think of 300 or 310 normally, and very commonly these multi-I/O cards that have a clock on them also use 300. That's a very common I/O address. So putting this in may not work until I take this floppy drive controller out. Now these cards have switches to change the base I/O, but the problem is the ROM that's on here is hard-coded to a specific base I/O. Well, hard-coded it and I mean that the chip that's on here is hard-coded. You can reprogram the chip with different I/O addresses, but you can't just change this on the fly. And these are all just some of the issues you can run into with systems like this. So I'm just gonna plug this in first and we'll just see what happens. But if it doesn't boot or doesn't see this card at all, what I will have to do is remove the floppy drive controller and then see if this works a little bit better. All right, so the system is powering up and we know XTIDE works if it doesn't freeze, first of all, and it should show the XTIDE banner. So there's, oh, there it goes. Oh, and it found it, 320. So I had changed it from 300 to 320. All right, it's booting the C drive. This is excellent because I have utilities. Oh yeah, of course, himem.sys doesn't work. I have utilities on this card that will allow us to actually test this floppy drive. Okay, so the computer has frozen because himem.sys was trying to run. Ultimately, I need to boot this computer by holding down Shift key, because this is MS-DOS 622. That'll skip all the auto exec bat stuff. It should just drop us right to the C prompt, and it does. So great. The system is working to the point where we can at least get into a DOS prompt. That is good. Who is curious about how fast this computer is? It's supposed to be a turbo 10 megahertz machine. Is it running at 10 megahertz when no switches are connected to it? Or are we at 4.77 megahertz? All right, well, there we go. It's not running in turbo speed. Sometimes you have keyboard control over turbo, like Control Alt and plus and minus on the number pad. Oh, it worked. I don't know which one I pushed, but whatever it was, it actually put the computer in turbo speed. If we hit F9, where's F9? F9, if we hit F9, which doesn't appear to work. The keyboard broken? Oh, sort of like lost the whole keyboard. F9 was not working though. That was to test the CPU. I don't know if I hit Control Alt plus or minus to change the speed. I hit one of those two and it did change the speed. We can kind of tell if we just do a directory listing. Okay, look at that speed there. And I'll hit Control Alt plus and we'll do directory again. That seems the same. Control Alt minus, much faster. It's sitting here counting up the free space, completely normal for XTs. It just takes a bit of time. I don't know why the cursor is up at the top. Weird. But let's run speed 600 again. This should actually calculate our CPU speed, and we have a big speed improvement versus the stock speed. So there we go, Intel 8088 at 10.005 megahertz. And the equivalent speed for this particular benchmark is around 5.1 megahertz for an IBM PC-AT. It is my recollection, if you run this on an original 5170 at 6 megahertz version, it would show a CPU speed of around 6 megahertz. So this Turbo XT, at least for the CPU in this benchmark, is nearly as fast as the PC-AT. Of course, it lacks 16-bit slots, so you lose a lot of performance with your video speed and your hard drive speed, but at least for the CPU number crunching part of it, it's similar. So I'm looking at the turbo switch panel again, at the turbo buttons specifically. I think there's an LED inside the switch because it has 4 wires attached to it. It is my assumption, looking at what's coming out of it, that the black wire is probably turbo and this is the LED because this has polarity and this doesn't. And once again, referring back to my photos, I'm glad I took them, that it would be the turbo LED and that would be the turbo switch is. Okay, and I have this hooked up and I think that is the case. Wow, it's extremely dim. I'm trying to shield the switch from the lights, but there are the lights off, there are the lights on. And the nice thing about this program is it's real time, so if I push the turbo button, there we go. So in this configuration, pushing it in slows the machine down. So I wouldn't be surprised if we swap the modes with the keyboard. Okay, so Control Alt minus again made it fast while the button is pushed in. Now if we do a directory listing and I do the button, it slows down. So it inverts the functionality of the button, which is kind of cool. And it definitely, the light turns on when it's pushed in. And in my personal opinion, turbo buttons should be pushed in for turbo speed. I know there's a great debate about turbo switch functionality, if it should be faster when you push it in or faster when it's out. Personally, I think it should be faster when it's pushed in because that's the turbo mode. This machine is a 4.77 megahertz XT and turbo is faster than stock, and therefore pushing turbo should speed it up. And all the later motherboards, 286s and onward, that had these turbo switches were really replicating this exact functionality you're seeing here. This was originated by the clone manufacturers, and therefore turbo speed meant faster than stock XT. So when you're using like a 486 with a turbo button, I know the speeds are then arbitrary, like what the slower mode is, but I still think the fastest mode should be when it's pushed in. My personal opinion. Comment down below and let the arguments commence. One thing I'm noticing is the cursor keeps changing. What changes that? Oh, it's like a turbo indicator. What? So if I push the switch, that doesn't do anything. In or out, but when I hit Control-Alt-, that does indicate a difference. What a weird little quirk for this particular BIOS. Now there's a BIOS routine that does this speed change, and it's also doing this, at least for the monochrome card. Okay, so obviously our floppy drive we weren't able to make work before, so let's run IMD, and let's see what we see. Now, if we take this floppy disk, the one I tried to boot earlier and it wouldn't boot, I'm gonna slide this in the drive, and I'm gonna do alignment and test, and hit enter. And if it's able to read the disk, well, we'll know pretty quickly. No, this is not reading at all. So we're just getting big question marks. Now this disk might not be good, so I'm gonna grab something else. I just grabbed a couple random disks, they're unlabeled, but usually these are formatted for the PC. The drive seems to be spinning way too slowly. Yeah, there's something wrong with the speed control, I think, on this drive. And that's why I can't read anything. Now there is an RPM function in here, but the problem with IMD's RPM function is it needs to be able to read the disk, I'm pretty sure. And if it can't read the disk, it will just give up. Because that's why it needs a formatted disk. Yeah, it just aborted. All right, so far we've encountered a bad floppy drive, well, a seemingly bad floppy drive, and a bad video card. So I think for now I'm gonna unplug this and we'll try a different floppy drive just to make sure that this controller card is actually working. But I'm gonna argue that there's something wrong with the speed control. Now interesting is this thing spins freely. So if there is a speed control issue, this has to do with this PCB under here. Typically the signal that comes from the top board is just on or off. This is not a dual speed drive, so this controller and these caps are handling all of that. Maybe we have bad caps. They're not surface mount. I don't see any corrosion, but I really don't think that this drive is running at the right speed. It just didn't sound like it. All right, I went into my stash and grabbed this 360K TAC drive. Let's see if this thing works with this controller. Unfortunately, the top-down camera battery died again. I know I need to buy a battery eliminator for this camera or just a new battery. So for now, you're not gonna be able to see what's going on the bench, but the TAC drive is connected. I have that compact 4.01 DOS inserted, powering on the computer, and I'm gonna try to boot off of it the XT IDE, which, the video card, the cable fell off. Let's get this connected quickly. Let's see if we can even read the A drive. Oh, it doesn't even have DOS on there anymore. Well, that's their problem right there. All right, I'll try to format the A drive with a /S. Ooh, it sounds bad, this drive. Why does it sound so terrible? It's kind of screechy sounding. Oh, okay, it's just the little cap that sits on top of the disk. If I put my finger on it, it quiets up. All right, there we go. Disk is formatted and the system is copied. If we hit Control-Delete, we should be able to boot right off the floppy disk. Okay, I hit A to boot off the disk, which should actually work now. DOS 622 boots kind of slowly on XTs, but it is reading the disk. That implies that this floppy drive controller that we had in here, there we go, we booted off the disk. Totally works. I mean, the drive is bad, but a different 360K drive does work. Now, as for the clock functionality on this card, I have a little clock utility on my compact flash card. I think it should be able to find that clock chip. There's no battery installed in there, but typically the way this works on XTs is you have to use a utility to address the clock chip, and then anytime you boot the system, you have to run the little utility in your AutoExec bat, which will load the time from the clock chip into DOS, because DOS keeps its own time. So you put date, like the date and time is obviously wrong because I didn't set it, but there's an internal timer on the motherboard that's keeping track of the time, and the clock is completely separate. I think this is a kind of a universal clock utility. Looks like this one's from 1991 by David Mutner. So right now what we can do is we'll first do T for diagnostic mode, and Yep, there we go. It found the MM58167 at 2C0. So I just set the date. Did that work? That actually worked. It's weird how it says enter date and it shows a 2-digit date. I tried that, it didn't work, but 4 digits did work. So there we go, 3:59 is perfect, clock. And now we can set the DOS time into the real-time clock. Now there's no battery in here, but it should still keep the time while the card is powered up. So we're gonna do U for update, and it says it did it. We'll do Control-Alt-Delete again. We don't need to use this floppy disk for booting. We'll use the XT IDE since it's faster. And right now, because I rebooted the system, the date's back to 1980. So if we run clock and we do S, it's gonna copy the clock time in the card to DOS. And now the date is correct in DOS. Oh, although, did I set it to 2026 or 2025? The time worked though, and so did the date for the most part. It's just a year off, but anyways, it kind of worked. And that just shows that this card would have worked, and it would have been great back in the day because you wouldn't have had to type the time and date every time you booted your system. It just would have been done automatically. Now we can run check it, and it's interesting for the BIOS, DTK/ERSO. I'm not really familiar with ERSO. Now check it is able to try to detect a few things, so it does show a parallel port and a COM port, which is correct. That's what this card has. It has a COM port and it has a serial port, and I guess it's configured as COM1 and LPT1. Now, question is our modem. Let's see if we can get this thing to work. I don't have anything to plug it into, but I just want to see if this shows up as serial port 2. Interesting is the modem has a little speaker on it, a little piezo thing, and it's making a noise. If I put my finger over it, kind of shuts it up. I think it's picking up the bus noise. So there we go, COM2. So let's try Procom Plus, because I should be able to at least, so we can see what kind of modem it is. I can try to query it. Okay, so F2 for COM2 are 1200 bits per second, Alt-S for save. So theoretically, yep, we got the modem. I don't remember a command that would like tell us what kind of modem it is. Obviously, we're looking at all the various parameters. Oh, you can store phone numbers in there, but no one ever did. ATI, it's usually like the I command that does it. Oh, okay, there we go, I3, AFC2500EO. That tells us literally nothing. And ATI4 doesn't work. Okay, so at 1200 baud, it works. Let's switch to 2400, which I'm sure is gonna work. Yes, it does. Yeah, I can hear the bus activity over the speaker. Let's see if it can detect a dial tone. Yeah, I think it can detect a dial tone. No dial tone. There would be an override for that. I just don't remember what it is. And how about 9600 bits per second? Yeah, still works. Now it's quite possible this is 2400 bits per second modem, but it has V42IS, I think it's called, or V42. It's like a kind of a compression, and therefore even the communication over the phone line is only 2400. It can actually interface to your computer at a faster speed because that compression actually makes you go above that speed of 2400 bits per second sometimes. So usually like 9600 is the maximum. Well, searching for this modem really brought up absolutely nothing. It's -E0 is the actual complete thing. And Google has to take away my quotes because it really couldn't find anything. I looked up the Rockwell part number, RC224ATL, converting the Rockwell 224ATL modem to a Zilog Z02215. What is this? All right, so the RC224ATL supports both a serial and parallel host interface. And looking at the feature comparison between this and the Zilog chip, which I guess is somewhat similar, says this does not support V23 or Minitel turnaround option, or Bell 202 or 202T, no caller ID support, V22 BIS. I have to look up what that is. I thought that maybe that was the compression and V42 was for later. Oh no, V22 BIS, that is just normal 2400 bits per second full duplex analog modem. So this pretty much confirms that this is a 2400 bits per second modem. So it's interesting it supports faster terminal rates from your terminal to the modem chip. Ah, this is the datasheet for the actual Rockwell chip. I don't know why I just didn't go to this originally. V22 BIS, 2400 bits per second, Bell 212A for 1200 baud, and 103, which of course is 300 baud. Oh, and it has fax capability as well, up to 900 bits per second. It says it supports V42, and V42 BIS can be supported through host software without additional features. Yeah, I'm pretty sure this was a compression I was talking about. Yeah, there it is. So that's probably why it supports those faster modes, so you can actually emulate the compression on the host side on your computer, and you would need to have faster than 2400 bits per second connection to the modem chip itself in order to support these compression modes. All right, sorry for that little bit of a tangent on the modem. There's really not much to do with this thing. You can't really use these. You can't use this as a serial port. It's because it's all integrated into the main IC. It's really doing all the heavy lifting. So if anything, this will not go back in the computer. I'm just gonna throw this into my scrap parts bin because occasionally I steal a part or two off of these old boards, and that's why I keep them. So we have two more components to test. There's a TIAC floppy drive and the power supply. So I'm just going to take this TIAC drive out of this enclosure, take the lid off and just check for dirt inside. And I'm sure this thing probably just works. Inside the TIAC drive actually looks okay. The fact that it's got a little flap on the front keeps a lot of that grime and that cigarette smoke out of it. I mean, my fingers still stink like cigarettes right now, but let's plug this in and see if it works. All right, so I have IMD booted up and I am just cleaning the drive. I have a cleaning disk in there. It's seeking without any issue. And after this is done, I will try a disk. Now the funny thing is about this BIOS I just reconfigured N format, it's seen that there are two 360K drives. So it doesn't really understand that this is actually an 80 track drive versus a 40 track drive. Let's try to format the disk anyways, it's gonna work. Now generally this is not a big problem. It's just that if you're gonna format a disk, the DOS format utility is gonna try to format it as a 360K drive, which is a 40 track drive. If you just change the format parameters to 80 tracks, it will work as a 720K drive. And I think the BIOS can use that without any kind of issue, generally. So this 3.5-inch drive is formatted with 40 tracks, which is why we only have 360K. If we change it to 80 tracks per disk, then we have 720K. Okay, here we go. Is this drive bad? No, this has got to be a problem with the BIOS on this motherboard. It's just got to be. We formatted the disk as a 360K, and that worked fine. We could try formatting DOS here, and I could try specifying the format as 720. And let's see if that actually works. Parameters not compatible. Okay, so that again is DOS thinking it's a 360K drive, and hey, you can't format 720. And I really thought that there was a command you could run in DOS to set the parameters of the disk drives. Don't remember what that is. I did a quick Google search and I think it's this driver.sys that allows us to override the BIOS. And typing in /D0 for A drive and /F:2 to override it to be 720, I think that might be what we need to do. This is all stuff that I've totally forgotten about. And I'm not sure I ever actually had to do this because I never had an XT. My first PC was a 386 because I was Apple II, Macintosh, even Amiga before I started getting my PC stuff. Loaded external disk driver for E. E? What's E? Is E now the 720K disk? Well, let's see what happens. That's kind of odd. So the A drive becomes the E drive because we've overridden the format to be a 720K disk, and it is formatting the disk. The drive is actually running right now. I wonder if you can use the substitution command, SUBST, to switch the A and the E drive after you've run this little driver here. You know, it's funny, playing around with this thing, I like to think that I know a lot about these old computers, but it's really interesting when I run into problems like this that just show that there's lots of gaps even in my own knowledge. We'll see if this actually works. And I did /S to see if I could try to boot this particular disk. This could have been why this was not the A drive and this was the B drive on this computer, simply because you had to run this particular utility with whatever version of DOS they had on their DOS boot disk. So you could even use this 3.5-inch 1.44 meg drive as a 720K drive. You can definitely not use it as a 1.44 meg, and that's because the controller on here only supports 250 kilobits per second. That's double density, so that's 720K. It just cannot physically write at 500 kilobits per second, which is necessary for high density. Okay, format complete. Copied the system. There it is. Format another. So theoretically, DE : should show command.com. Yep, there we go. But if we do A:, it's going to give us that media error. Oh, they didn't. That actually worked. So I don't understand what the E is for then. Let's try booting and seeing if it can actually boot off of itself, even though it doesn't really support itself. So I hit A to boot off the A drive. It's accessing the drive. Oh, it's actually working. Okay. Well, this definitely proves that the combination of this drive and this controller and this motherboard do work. You just have to finagle it a little bit. Okay, at this point, we've determined that everything is working except for the 5¼ inch floppy drive and the video card. What we haven't tested yet is the original power supply. I'm gonna reorganize the bench a little bit. Let's see if this thing works. So this power supply has a kind of nicotine glaze, and I used a bit of magic eraser on the outside, and it's a bit better. You can still see some of the glaze on there. Magic eraser came out with this dark brown color, kind of gross. I took all the screws out, so this top theoretically should come off. When you have one of these power supplies, you just kind of have to figure out the jigsaw puzzle. That is the assembly method. It also helps to get all the screws out, which I did not do. Now, one issue with this power supply is that it will be cigarette smoky, and as soon as you power it on, it's gonna smell bad. And that is really horrible. That is really horrible. So as soon as this thing warms up, the smell of cigarette smoke is gonna kind of emanate from this, and then the fan will blow it all around your house. Awesome. At least with this power supply, you can unplug the fan. Now, I have to give you a warning. If you're gonna open up a power supply, it's pretty dangerous. There are high voltage caps that can hold a pretty substantial charge. They will fade with time, but if you have recently plugged it in and you touch the bottom of the board, you can get a good zap. Now this power supply, which incidentally is kind of completely unbranded, it just has 150 watts switching power supply, does have a voltage switch on here. So you gotta make sure that it's set correctly before you power it up. 115 volts, no problem. The smoke encrusted dust that's in here is pretty gross. And there's definitely a strong smell of cigarette smoke in this thing. Yeah. Anyhow, what I'm really here to look for are any caps that look like they're problematic. These are vented type and they look all fine. Let's see if anything else looks problematic. It's dirty. It's the bridge rectifier. High voltage caps. Doesn't have a refa. This power supply is very cheaply constructed. The original XT power supply was much larger, a lot more components. This thing is very much built down to a low cost. So much so that if this thing doesn't work, I'm not sure it's really worth that much effort to try to fix this. There are many solutions you can do with one of these power supplies. One thing we could do, obviously, is just put a brand new power supply inside this case, since this metal chassis here is the unique part to the XT power supply that's hard to find these days. This inside here, pretty simple stuff. In fact, we already shown that a regular ATX power supply works fine, and clearly that would probably fit inside of here, especially if you use like a Pico ATX. All right, for power testing this, I'm gonna use some of these lamps to give it a bit of a load. So we have two car light bulbs. One is on the 12-volt rail, and I have this one hooked up to the 5-volt rail. And even though these are 12-volt bulbs, they do light up just dimly at 5 volts. They just take a little while to light up. I have the mains connected, so now this thing is dangerous and hot, so don't stick your fingers anywhere inside of this thing. Let's see what happens. Well, it's running. Let's just check the voltage rail. So we're on the 5-volt rail. 5.0 whatever, 9, looks good. 11.697 for the 12-volt rail. Looking good. Now, there are some minus rails that are on here. Is it worth checking those? Sure, let's plug the minus, or let's plug the ground into there. It's nothing. How about this blue wire? Minus 12 looks good. And there's minus 5. So all the rails look good on this old thing. Wow. All right, this thing works. That means I think I need to take this out of there and give it a full clean. And of course, since I have run this, that means these caps may be charged up. Could give me a bit of a zap. And while I have the board out, I'll be checking the other side for bad solder joints, things like that. You know, the underside of the board actually looks pretty good, but I'll give that a once over. I can tell you now, I'm throwing this fan in the trash, and I will be putting a brand new fan in there. There's no way I'm putting this back into operation. It will stink up the house as soon as it runs. Okay, I have the main board back in the power supply, and everything looks good. There were a few joints on the bottom that were suspect, so I touched those up. I did swap out the fan for a new one that's not so gross. All right, let's try this again. 3, 2, 1. There we go. Fan is running. Power supply is on. Excellent. And now we have the final bench test before I put this thing all back together. Let's see if this power supply works powering up an actual load, a real motherboard here. 3, 2, 1. There we go. I mean, it's unhappy about no video card. It's funny, we're seeing an FF. We didn't see that before. Anyways, this is running. Fan is spinning. We're looking good. I think it's time to put the computer back together. All right, the machine is back together, still not tested. I didn't put in the video card we were testing with. I decided to put in this ATI Solutions Rev 3 card, something I recently worked on a mail call episode. This is a CGA/Plantronics compatible card that a viewer sent in, and I did a repair. So I'll link to that video down below if it's already been released. If not, then I'll put the link eventually. I obviously put the original clock floppy drive multi-IO type card back in. I did put a battery in it, CR2032. It's not exactly the right type, but it's good enough. I did use a different ribbon cable for the floppy controller. I didn't want to use the original one that was all smoke encrusted. Luckily, I have a bunch of these. I did have to crimp on an extra connector though, because the one that I had handy has a pin header, so no problem there. Original power supply is back in, original motherboard is back in. I reconnected all the cables exactly how they were connected when we first took the computer apart. And for the floppy drives, I obviously put the 5¼ inch on the top, and I used a good 360K from my stash. Obviously the original one is gonna need a repair. And underneath this drive is the 3½ inch drive, which I have set up as the B drive. This is the A drive, hence the twist in the cable, because that is how it should be. The A drive should always be on the top, at least in my opinion. The power cable is connected to the power supply. Let's turn this on. 3, 2, 1. Nice. Okay, well that's not good. It's acting, well, I think it's acting like there's no video card in there, but clearly there is a video card in here. Oh, you know what? I just realized that this is a CGA type card, and the dip switches on the motherboard, which are underneath this rat's nest, are going to be configured for monochrome. Now we know this is not an original IBM PC XT motherboard, it's a clone, but usually the clones follow the same dip switch settings as the original XT, just for simplicity's sake. According to this chart, switches 5 should be on and 6 should be off for 80 column CGA video. Yeah, currently 5 and 6 were set to off and off, which indicates MDA video. And the current configuration for 7 and 8 are on and on. One floppy drive, even though this has got 2. It should be off and on. I don't think you can even see the switches. They are down there, sort of behind the wires. Okay, let's see if that made a difference. Yes, that is a normal beep. Okay, good. Since I have switched the video card, we're gonna have to switch this into CGA mode. There we go. Let's turn this on. Is the cable actually connected? Oh yes, there it is. Keyboard error. Yeah, I didn't plug in the keyboard. It's so beepy. Wait. The floppy drives aren't working? Really? Okay, what we don't know is if this card works. So I think I'm just going to, we'll turn off the power. We can take off the postcard. We don't need that anymore. And I will stick in my XT IDE so we can boot up and try and see if we see like the serial ports and the clock on this card. I want to know if it's making good contact in the ISA slot. All right, well, check it shows A drive as present. I think that's a lie. It does show the COM port and the parallel port working. What we should run is the clock diagnostic, see if it sees the clock chip. It does see the clock chip. Uh-oh, well, what happened on the floppy drive controller? Is this a problem with the drive controller itself? Is this a problem with my cable that I made? Are the drives not working together? Huh. Okay, I figured it out. The cable I was trying to use is the one in my right hand. This is the floppy cable in my left hand. Notice the twist is in a different location. The cable I was trying to use is an MFM hard drive cable, which some of them have a twist in them. And I knew one day I would get caught out by this. I just grabbed this cable randomly because it had 2 of the edge connectors on it. And well, clearly that's not gonna work. So what I'm gonna do is I'm just going to take apart this connector, the end one with the twist, and I'm gonna fix it. I'm gonna put the twist in the correct position for floppy drives. And this is the converted cable from MFM to regular floppy controller. Yeah, I just put that back straight through and twisted over the correct cables. And I just take these connectors apart, peel them off, and then I use a vise to put them back together. I don't have the correct crimp tool for these types of connectors, but the vise, that always works pretty well. So I'm just gonna first start by connecting it like this before I try to get my hands down in there to hook up the second floppy drive. Hey, let's see what happens when we turn it on. Come on, fingers crossed. The floppy drive actually seeks. We might get an error because it might look for 2 drives. Nah, but the floppy drive seeked, perfect. All right, and both drives are connected again. Let me just set it back to 2 floppy drives as I had it originally. I don't think it necessarily matters, but in case it does. Now, interesting is it only seeked the A drive, even though I have it set for 2 drives. Let's see what it says and check it now. All right, first I'm going to fix this driver.sys, and I'm going to point it to the second drive. Even though it's not seeking the second drive, and I have it set for 2 disk drives on the switches, I'm just going to set it for that 720K disk because we definitely needed it before. And according to Check It, floppy drives A and B seem to exist. Good. I'm going to reboot now that I fixed that driver.sys, and we should theoretically be able to read this disk we formatted earlier. I mean, the B drive light's on. Yeah, there it is. Okay. And there we have it. The NCC Turbo XT is all back together, looking pretty good. I've actually been using it for a couple hours, and I'm surprised, but it doesn't smell like cigarette smoke too badly. Just the tiniest whiff of it. I did use a magic eraser and do quite a bit of wiping down of the inside. I used multiple magic erasers, and that is just some of the nicotine tar that got removed from magic eraser. This seems like a pretty effective tool, at least wiping down the surfaces and getting off the nicotine. Now you may notice the Commodore 1084, I have this hooked up via CGA to that video card that's in here, the ATI Solution Rev 3. I have my Hayes modem emulator set up and ready to go as well. The XT IDE is inside the computer, but I have prepared a boot disk and a program disk for us to test this thing out as it was used, presumably when it was new. So I'll pop in both disks. Now I have the lights off so you can see the monitor clearly, but let's turn on the computer. It beeps, there's our screen, and then the turbo LED comes on. And I'm gonna push the A, so it boots off the A drive. Let's boot DOS. Now you notice the clock utility is on the floppy disk, so it does set the date and time from the multi-IO card that's in the computer. And as I said, to simulate the use case of this hard drive-less computer back in the day, I have Program Plus on the second disk drive here. So we'll just run that. Program Plus 1.1b, it's from 1988, so perfect time period from when this computer was being used by its user. They bought this thing in 1988. Now I have a few things in my phone book. Now this is a modem emulator. This is connected to my network, and this can dial up in air quotes, to Telnet BBSs or anything that's on Telnet really. So I have a Docker container running Alpine Linux locally, and let's dial up to that. Now, I used to use Program Plus and remember that sound when the thing connects. Pretty funny. I used to use Telex, which was a Program Plus-like program, very similar, and Telex had its own set of sounds that are just burned into my memory. So the stuff that Program Plus does is not exactly what I remember. If anyone knows where to get a full unlocked version of Telex, let me know, because last time I looked, I wasn't able to find one, and this shareware version really is too crippled to use properly. To dial this again, obviously I can just dial through the dialer, or I just type /, which will cause the modem to dial the last thing that it connected with. And there we go, we're logged into this Docker container. So I have a few things on here. Let's see what we have in here. There's some stuff that we were demoing on the VT100. So if I type like cat moon animation, there's a moon animation. Now this stuff is all designed for the VT100 and not PC, so it doesn't really use any kind of color, which this thing does support. But it's funny because Linux does support color and it is using it. So if we look at a directory like user bin, there we go, we have full color working here, which obviously on a VT100, you would not see. Now, who knows? Back in the day, it's quite possible that whoever had this computer was dialing up into a mainframe, and that's the kind of work they were doing, which is why they didn't even need a hard drive. They just needed a boot disk and a terminal emulator to get connected to whatever mainframe or BBS they were using. So on this Docker container, I have Frotz installed, which is the interpreter for all the Infocom games. This is an open source project, and you can just load any of the DAT files from the Infocom program. So this is Planetfall. And there it is. Planetfall is running now. It's on a Docker container, but we were able to access it. So maybe back in the 80s, someone was using this thing to access games remotely. Who knows? Why don't we try a BBS? How about 20 for Beers? A local Portland BBS, which has full ANSI graphics. Oh, we're going to have to switch into ANSI mode, though. Now, one thing about this BBS, which is pretty funny, is it seems to be designed for a much faster connection than the 9600 baud that we're using here. And therefore, a lot of the graphics just kind of, they're very sluggish because it's constantly buffering them, I guess, in the modem as it sends the data to your terminal. So you have to push X twice to get logged in, and I did that, and we're still getting the countdown. I think there we go. Relax and stay a while. Okay. I love ANSI graphics, and it looks so good on the Commodore 1084. The colors are so vibrant. Look how cool that looks. Who remembers dialing into BBSs from your PC or other computer that had ANSI graphics, and you got stuff like this? It's just so awesome, so creative. And yes, 20 for Beers is a local Portland BBS, so if you haven't checked it out, I'll put a link in the description to info about it so you can try it out yourself. It's so awesome though, look at this. Check out the shading though, look how awesome that looks. This is all just text mode what we're looking at here. It still looks awesome. And one of the issues is 24 Beers doesn't want me to have the status line because it's using all 24 lines, but this version of Program Plus, I couldn't figure out a way to turn off the status line. So it causes a little bit of weirdness with the contents of the screen, sometimes scrolling when it shouldn't. And yes, in case you're wondering, 24 Beers has plenty of door games you can play, lots of other stuff you can do, message boards, the whole 9 yards. I really recommend checking it out if you were really into BBSs back in the day. And doesn't that look fantastic on this old IBM PC XT? Yes, it really, really does. Okay, we're done with BBSing for now. I hit the reset button. I'm gonna remove this floppy disk and the other one because we're gonna boot the XT IDE just because it's quicker and easier. Because I wanna do what I said I would do at the intro, and that's actually play a game locally on this freaking computer. And I was about to try Paku Paku, which is an awesome Pac-Man clone for the PC, but it says there's a runtime error. Even after rebooting, Paku Paku still didn't work. It gave that runtime error. It might be corrupt on my Compact Flash card. I'm not totally positive. Let's try David Murray's Attack of the Petsky Robots. And this is one of the few games that fully supports Plantronics graphics. And look at that, looks freaking awesome. And let's see, it should be working really well. And yep, it is. It's not the fastest animation because of course we are running on such a slow computer, but it does work. As you can see, it's quite responsive really, considering this thing is 10 megahertz. What if we turn off the turbo? Oh yeah, you can really see the draw speed there. Oh boy. Yeah, that makes a big difference with turbo on, turbo off. Now, one thing I'm not super familiar with is the keyboard interface on the IBM PC version of this game. So I don't know how to take action, like search things or move things around. So normally you would go into these rooms and you would search for things and you could find a pistol and you would find weapons and tools and magnets and things you can use to attack the robots. And without knowing the keyboard controls for moving things around, not 100% sure how to do that. But we can see the game looks fantastic in Plantronics mode and it plays well too. Now, I'm not really familiar with what other games support Plantronics mode besides Planet X3, that's David Murray's other PC game. But if we run the Sierra game Thexter, for instance, it's a loudspeaker. All we get is the normal CGA graphics with this color scheme. And the game should play okay. Yeah, how do you turn off the music? I don't know. Oh boy, there we go. The animation's not so bad. It's just the music's kind of obtuse. There could be there's probably a key to stop the music. Okay, it's the M key. That stopped the music. So now we just have sound effects. That's a lot better. You know what? This is not too bad for such a slow old computer. Oh no. Go away. Go away. I definitely remember going to my friend's house, Dave, and he had this on his PC. Oh boy. And I think he had CGA graphics, so this is exactly how the game looked. I feel the designers of this game did as much as they could with what they were given with what CGA could do. Okay, go away, you guys. Go away. No. And with that, that is it for this video of PC archaeology on this old NCC XT Turbo clone. I'm left with a pretty nice and fully functional computer, which is pretty awesome, although we do have some bad parts. So there was that monochrome printer card and the floppy drive, which is not working. And if you'd like to see me do any repairs on these two parts in a future video, let me know down below in the comment section. I think it's always kind of fun to try to troubleshoot, especially things like digital electronics like this monochrome card, to see if we can figure out what's wrong with it and maybe if I can get this working. This has custom ICs on it, so if those are bad, then it's obviously nothing we can do. But if some of these other support logic chips are bad, well, then it should be something that we could maybe fix. If you enjoyed this video, you know what I'm going to ask you to do. Hit that thumbs up button. But if you didn't, you know what to do as well. You can hit that thumbs down button, hit that subscribe if you haven't already. Thanks to my supporters. Their names are going up the side of the screen over here. They make it possible I do this full time. Without them, I really would have to get a job, and that would kind of suck because I really love playing around with this old junk and making videos for everyone to enjoy. And lastly, if you happen to know anything about this NCC computer company here in Portland, I would love to hear about it down in the comment section because it'd be cool to figure out a little bit more about the history of this PC clone. And I know these things were a dime a dozen, but still it's kind of cool to know that this thing was put together here in Portland. And I guess it's lived its entire life here. And I was able to get my hands on it and save it and get it up and running and looking nice and clean again. So that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.